Hey everybody, it's your boy Mr. Clausen here. I just wanted to go over naming and writing chemical formulas for covalent compounds. Now, we spent a lot of time in class talking about what a covalent compound was. Remember, it's just when a metal is bonded to a nonmetal and they share electrons. That's not the main point of this one. This is mostly how to go about how to name and write their chemical formulas because it's a little bit different from ionic. What we'll do here is we'll start with probably the best example for this. And so the first example we're going to take a look at is a compound made of carbon and oxygen. And so if we use our naming rules right now, we would call that carbon oxide. All right, take a look at the other one. It's made of 2 oxygens this time and 1 carbon. And if we use our current naming rules, we'd still call that carbon oxide. Now you can already see that this is a bit problematic because we have 2 words describing the same word describing 2 different chemical compounds. One with 1 oxygen, one with 2, and these are completely different substances. Now one's toxic for you and one you actually produce when you breathe out. And from your everyday life, you probably know that the first one out there, this one right here, is called carbon monoxide, and this one right here is called carbon dioxide. And that's exactly the difference here for how we name them. So I made a little typo there. There we go, we call it carbon monoxide, and then this one is called carbon dioxide. And the difference here is all we have to do to name these compounds is we add something called a prefix that just basically tells you how many of each type of atom is in the compound. The prefix mono means 1. If you take a look over there, there's only 1 oxygen, all right? And right here, the prefix di means 2, and if we take a look over here, there's 2 oxygens in that one. All right, so here's the list of the prefixes you would have to use, so please copy these into your notes. Mono is 1, di 2, tri means 3, tetra is 4, penta is 5, hexa is 6, hepta 7, octa is 8, nona is 9, and deca is 10. I'll pause the video here if I went too fast, but get these down because you need to reference them as we go. So let's go through some examples now. All right, so we'll get rid of the last example, and we'll put another one in here. Okay, so the first one is, as you can see, it's made of phosphorus and oxygen. So instead of calling oxygen, we call it oxide. Now the key here is you have to use the prefixes to it. So if we take a look, we see there are 2 phosphoruses, so we use the prefix di. And then if we take a look, we see that there are 5 oxygens in this one right here, so we'd have to use the prefix for 5, which is penta. And if you put the whole thing together, you get diphosphorus pentaoxide. Try the one down below. You can see it's made of carbon and chlorine. But remember, instead of calling it chlorine, we got to call it chloride. And then we simply just add the prefixes to it. So we go ahead, we'll put this one in. And you may be tempted to put the prefix mono out in front here because there's only 1 carbon. But we don't do that. It's a little bit special. Mono only gets used if it's the second element inside the compound. So since carbon is the first one, we don't go monocarbon. We just basically just call it carbon because it's already there. The chloride, though, the prefix we've got to use for that is there are 4 of them. So we're going to have to call that tetra. And so the name of this stuff right here is carbon tetrachloride. Remember, don't use mono if it's on the first element. So if it's on the first element, you don't use it. You only use mono if it's on the second. All right? This example will be made a little bit more clear on the next page. All right, next page. I'm going to go ahead and get rid of that, get all those marker marks out of there. All right, so here we got 2 compounds, both made of nitrogen and oxygen. So we call it oxide. Let me call this one nitrogen oxide, but we can see that the 2 is in a different spot on each one. And this is a really good example of when you use mono and when you don't. So up here, remember, even though there's only 1 nitrogen, we don't use the prefix mono. We only use it if it's on the second element. But in this case, we've got 2 oxygens, so this one would be nitrogen di for 2, so nitrogen dioxide. And now down here, what we end up doing is we see that there's the 2 on the nitrogen, so we call this dinitrogen. And now since the second element in the compound is the one that only has 1 of it, now we can go ahead and use mono, which is a little bit weird when you got the word oxide. You saw me make a mistake on this before. You just don't put another O in there. you just use the O from the oxide to begin with, so you'd call this dinitrogen monoxide. I wrote it a bit poorly there. Let's see if I can pretty this up a little bit for us. There you go. That's how it would look if you took the time to actually write it out proper way. Two separate words, neither one's capitalized unless it's the beginning of a sentence. All right, then we got one more to take a look at. And this is how do you go from the name back to the chemical formula. And it's really quite simple because all the information is right there as long as you know what the symbols are. So just remember that the symbol for phosphorus is P, and that the symbol for chloride there, if you take a look, chloride, is chlorine. And all we have to do is take a look and see what prefix is in front of that chlorine. So if you take a look, you'll see there's no prefix on phosphorus, so it's all good. But if you look at the chlorine, it has tri in front of it, and so all that means is there's a little 3 underneath it. Okay, take a look at the one down here. You'll see that we have dichlorine heptaoxide. So try and find the chemicals that are involved there. You find the word chlorine, so you're going to use that. And then oxide, so that's oxygen. And now what we have to do is just look at the prefixes. So there's the prefix di in front of the chlorine, so there's 2. And then heptaoxide, which means hepto, if we look up on the list, I had to look for it. So there's the list down there. It's number 7, so it means we have 7 oxygens. So that's how you go ahead and write the chemical formula based on the name. If you have any questions, come talk to me in class. That's all we got. We'll see you later.